Okay, so let's talk about similarity. So let's first talk about congruent figures. Congruent figures are congruent if they are the same size and the same shape. Okay, same size and the same shape. The angle measures and the side lengths are exactly the same, but they do not have to be oriented the same way. Does everyone know what that means when they're oriented the same way? What they mean is, I'm going to show you two rectangles that are congruent. These two rectangles are congruent, okay? They're the same size and shape, but they're not oriented the same way. Would you agree with that? One's kind of horizontal flat and one's tilted. That's what they mean, okay? They just don't have to be oriented the same way. And if we label them, then they would probably have different labelings. Labeling by the vertices. We would put A, B, C, D, and this one could be D, E, F, G. Okay? And they don't have to be oriented the same way. Okay. So the congruence just means same size and shape. Any questions? Okay. Determine if the set of figures is congruent or not. Label them and justify your response. So here's what we're looking for. Let's look at the first one together. So do we want to know if ABCD is congruent to PQR, OPQR? Obviously not. That's a big no. Uh, which of the qualities of um, congruence are they missing? Yes. Yeah. Not the same shape or size. So let's just say that. Okay. So not same size and shape. Okay, so I want you to do 2, 3, and 4. Look at the values. Compare the values, and that way that will help you to determine that. So I'll give you a few minutes to look over those, work with the person at your table, and decide on 2, 3, and 4 if they're congruent. All right, so let's look at number 2. Let's decide yes or no on congruence. No? Oh, okay. All right. And so is that same size and shape? Okay, I agree. How about number 3? Yeah. If you compare what we call corresponding sides, they're the same 4 centimeters, 4 centimeters, 3 centimeters, 3 centimeters, and 5 centimeters. Okay, so this is yes and same size and shape. Okay, how about the last one? No. And obviously not same size and shape. It is the same shape. I guess, yeah, I guess yeah, let's just say not the same size. Good catch. Thank you. Um, Now, the other quality that we're going to focus in on is when objects are similar. So, in order for figures to be similar, they must be the same shape. So, they must be the same shape. The corresponding angle measures must be equal. Another word for equal is congruent. Okay, so they must be the same shape. The angles have to be congruent, the same measurement, and the corresponding side lengths must be what we call proportional. And it's always going to appear that one is like you got a larger one and a smaller one, like a little mini me of one of the shapes. Okay. So let's go ahead and study this a little further. The figures below are similar. Determine the corresponding angles and corresponding side lengths. Okay, so we want to find out which angles from one triangle to the other match up or correspond. So let's start with angle A. Um, which angle would correspond to A? D, yeah. So angle D. How about angle B? E, yeah, that's the one that's also 90 degrees. And that we have that helping us out. And finally, C would correspond with angle F. Okay, so now we got to find the side lengths that correspond. Um, let's start with AB, DE. So those correspond. Okay, and then let's move on to BC, EF. It helps if we color code them. I've always found that helpful. Okay, and finally we have CA, FD. Okay. Okay, so now that's going to be very important when we're working with similar figures. We have to figure out which parts correspond, which angles match up, which sides match up. Okay? Okay. All right, now let's learn about scale factor. Scale factor is basically a ratio. So the scale factor is the ratio of corresponding sides in a figure. So let's say we have these two triangles, ABCD and DEF. ABC and DEF, okay? And we're going to make a ratio. If we're saying that the original one is the larger one and the newer one, the smaller one is the newer one, we're going to make a ratio of corresponding sides, okay? So we take, for example, 4 from DE and 6 from AB, and we make that ratio. And then if we have to, we reduce it. And you see how we got 2/3? This is our scale factor. Okay? So Kaylee, would you read that for figures?
For figures to be similar, they must have the same ratio or scale factor. The shapes are labeled by corresponding angles, so they will start in the same point and go in the same direction around the shape.
Okay. So one way to tell if we have similar figures is to see if they have the same scale factor. So we have these two rectangles, GHIJ and KLMN. And we're going to prove that the figures below are similar by finding the scale factors. Okay. So let's make a scale factor. So let's say that this is the original and this is the new. Okay? So let's make a scale factor. So let's start with KL over GH. The new to the old. What would that be? 20 over 5. Okay. Let's reduce that. What does that reduce to? 4. 4 over 1 or just 4? Either one is fine. 4 over 1. If you said 4 over 1, that's good. 4 is fine too since it's a whole number. That's not good enough though. We just compared these two values, which because we have rectangles is also the same as this one. So we did half the work already. But what else do we have to compare? Yeah. You got to compare those. So this time we want KN, compare it to GH or GJ. We got to compare those. So what are the values for those? Okay. We can simplify that. What's 10 divided by 2.5? 4. Okay. And lo and behold, we found the scale factor. It's 4. Because it worked for both of them, that's the scale factor. Okay. So these two are similar. Let's work with the next one. We have two triangles this time. So I'm going to pick a side, and you tell me what's corresponding on the other one. I'm picking FG. What corresponds to FG? NO. So let's figure out that ratio. We want FG to NO. And that would be 6 over 3. Okay? And that becomes 2. Okay? Let's pick a different one. Let's pick FE. So if I pick FE, that has to be NM. And that's going to be 5 over 2.5. 2 again. Okay? And so the last one is EG to MO. And that gives us 7. So we got the same scale factor in all of them. So are they similar? Yes. So they're similar, and the scale factor is 2. And if we reverse it, it would be 1 over 2, or 1/2. Okay? Okay. Um, so, based on questions 6 and 7, what do you notice about the scale factor for enlargement or reduction? I'll give you a hint. In both of these, we were going from this original, we went from this original to this one. I always went from the smaller to the large. And do you see how the scale factor was in this number? But if we were to go in reverse, say I were to go from, say this was my original, and this is my new one. If I'm going from this original to this new one, am I enlarging or reducing? So then the ratio wouldn't be 4 over 1, it would be 1 over 4. Same thing here. If this is my original, and this is my new one, I wouldn't go from 2 to 1, I would go from, then my scale factor would be 1/2. So basically, it depends on which one's your new and which one's your original. Okay, so based on the question 6 and 7, the scale factor of an enlargement and then the scale factor of a reduction, what do you think the scale factor of one would be the result? So if the scale factor was not 1 to 1/2 or 4 over 1, but just 1, if the scale factor was 1, what would the change in the size be? Yes. There would be no change because the scale factor tells you by how much you grow or how much you reduce. So maybe since the scale factor determines the growth or reduction scale factor one means stays the same, stays equal, I'll say, since I'm running out of room. So if the scale factor is 1, it's not going to enlarge or grow. If the scale factor is over 1, like 2 or 2.5 or 7, it's going to grow by that much. If the scale factor is between 0 and 1, like 1/2, 1/3, then it's going to shrink by that much. Okay? Okay, so last question. Trapezoid QRST is similar to trapezoid WXYZ. Determine whether the statement is true or false. Okay, let's see, true or false. So these are similar. Angle QRS, let's find QRS. QRS is this one. Is congruent to angle ZWX. Let's find ZWX. ZWX. Are those congruent, the same size? No. They don't correspond. They don't match up. So they won't be the same size, probably. That's a false. Okay. Let's see. RS over XY. So let's find those. RS over XY. I'm going to use a different color. Is equal to ST over YZ. Let's see if that's true. RS over XY. Well, those correspond, right? These two correspond. Is equal to ST over YZ. Do those correspond? Do they match up? So they would be equal. So that would be true. Okay, I'll leave the last two for you to answer. I'll give you a little bit of time, then we'll come back to it. So check with your partners on the last two, C and D. So let's come back so we can get to work. What do we think about question C? True or false? Yeah, that's true. So far, so good. Last question. ST over YZ is the same as WZ over QT. That one's false. Yeah, they weren't corresponding. So that's not going to work for us.